Hello guys and welcome back. So now I have increased the point count, so I have more wires, and I increased this from the point count from 250 to 1250, and then I run a sim of 400 frames, and this is how it looks like with the current wires. And you see they are getting entangled and intersecting with each other. I also turned off the facet node to get a more uniform distribution of the points, and this is better for the sim. Okay, cool. So the next thing that I want to look into adding is those animated lights. And the idea here is I want them to start at the origin and then travel at a different speed and then reach the target. And I want to explain this idea on a single curve. But first, let's choose a frame. Okay, so I'm going to put down the time shift to freeze the time. I don't want the curves to be animated. Okay, and I'm going to isolate one curve to start with. So let's grab any one of them. Delete non-selected. I will want to have a point that travels along the curve. We know for certain that we want the points to start at 0. Okay, so we have, I believe if we inherited that data, we have the glue to animation. Okay, so I'm going to do it by hand for now, or maybe we'll do for each loop. That's fine. So I'm going to use this that identifies the start and end of the curve, and we'll do that here. We did this in the beginning, so I'm going to call this start, I'm going to call this end, and we initialize the start to be 0 for all the points and end to be 0 for all the points. Okay, cool. So now we should have that attribute. Okay, let's isolate the start point. Points, delete non-selected, and we have our points. And the idea is we want this guy to travel along this curve. And what we're going to use is something called the prim-UV, or a lookup into a geometry using a UV coordinate, using its UV information. So let's first make sure we have the correct UV coordinate. I'm going to set this to R-spline and set it to point. And let's say we call this point, and let's call this curve. Okay, and let me draw something quickly to explain this better. So let's say we have a curve, a random curve that has 0 to 1 UV coordinate. Okay, so 0 to 1, and anywhere on this curve we can say, okay, what's the UV coordinate in there? So here will probably be 0.2 along the U direction, because the V will be 0. Here it will be 0.5. And what we can do is we can say, okay, for a UV coordinate of 0.5 and 0, give me the 3D location of that point in space, in 3D space. So we can do a query on this curve using this input. Say, give me the location of the 3D point that have a UV coordinate of 0.5 and 0. So it'll probably be somewhere, it will give us back a X, Y, and Z coordinate. That would be, let's say, 15 on the X, 20 on the Y, 30 on the Z. It will be a vector. So if we can get a point animated through time that has a value that goes from 0 to 1, it starts 0 and then goes to 1, and for each increment we use that information to do a lookup on this curve, and whatever value we get back, we change the point position to match that. Okay, now let me show you how this works in Houdini. Now we have a point and it's number 1 number 0, and we have a primitive and it's number 1. We use a point vol, connect the points first, my single point, and then a UV, the primitive. Let's dive inside. I'm going to use a primitive attribute node, and this what will allow us to do the lookup using the UV coordinate. So the geometry that we want to do the lookup on is the second input. So I'm going to connect this to the second input. The attribute name is not color, it's the P position. Okay. The primitive number is number 0, which is controlled here. So we can create a constant. Say, okay, the primitive that we're interested in is 0. If we have 2000, we can use the primitive number to identify or query a specific curve. Cool. So let's now we have the result back, and we're going to set this back to change the position of P. Now nothing changed, and the reason for that is because the UV coordinate is returning the first point. So if we slide the U coordinate, it's doing a lookup using this U information, and then it's returning a 3D coordinate from the curve. So if we have, let's say, instead of just one point, we isolate all the first points of these curves. So let's do that. Let's remove this blast here. So we work on all the curves. We have all the start information. And then if we change the P, you can see they're all querying the primitive number 0. So what we need to do is we need to give each point the correct primitive that it needs to look up. So see this point here, it needs to look up the primitive corresponding to that, not just number 0. And so what we're going to do is we're going to create a primitive ID attribute. I'm going to call this prim ID, and it's equal to the prim num. Okay, so now we are storing the prim num as, let's find it. Now we can type the search here, or prim ID, I think we called it. What did I call it? Prim ID. Come on. Yeah, it's here. So I don't know why it's not showing up. Yeah, so it's here. It's fine. And we have that information, so we can track where this point came from. We know which primitive it came from. So inside this part here, we're going to bind import that prim ID, and then we're going to change it to an integer and connect this instead. So see, all the points are now snapped correctly, and if we change the U coordinate, you can see they're all doing a lookup over the curve that they need to import from. So all we have to do is generate a loopable number for these points that starts 0, 1, 2, 3, 4, 5. This starts at 0 and ends at 1 over, let's say, 24 frames, for example. So what I'm going to do is I'm going to use a particle sim for that, so we can control it nicely. And I'm going to change these points position to match their point ID. So I want to straighten them out from 0 to 1. Okay, because it doesn't matter where they are in space. I can even set them all to 0 here, and this system will still see they're all now at 0, 0, 0. This will still work just fine. Okay, so let's do this. Let's, instead of setting all the point position to 0, I'm going to set it to be equal to the point number. So on the X, sorry. And then I'm going to 0 out the Y and Z coordinate. So Y is going to be 0 and Z is going to be 0. And now we have all the points straightened out from 0 to 7, 7, 8. So that's the last point. And what I'm going to do is I'm going to create a particle sim that shoots these points up randomly and until they hit specific height, and then they die every 24 frames. So let's create a pop network. And I'm going to say all points. Okay. And then I'm going to add to or set initial velocity. I'm going to give it a value of 3 on the y, and then randomize it by 1. So not all the points have the same information. You see they're going up, but right now they're all emitting. They're emitting multiple times, so we just need them to emit one time, and or every 24 frames. So I'm going to say $f modulo 24 is equal to 1. So what's happening now is every 24 frames, every time this number can be divided by 24 and the result is an integer that is equal to 1, then it sends a signal. So this is only true for when that condition is met. So it's 1, it's going to be 1 again at 48, and so on and so forth. And so if we set the life expectancy to be 1 second, which is 24 frames, and that's identified here as well, that means we're going to birth 24, 24, and so on and so forth. And we can also randomize the variance if we want to, or add some kind of offset to change the points if we wanted more randomization. But let me increase this to 10 and this to 3 to have more randomization. Okay. And what I'm going to do is I'm going to import those points again. This is, by the way, just one way of doing this thing. It doesn't mean that we have to do it this way. Any way you can get a loopable number per point is fine. It doesn't have to be a sim. And I'm pretty sure there is an easier way to do this without the sim. This was the quickest way for me to think of. So I'm going to copy that name and fetch geometry. I want to import the geometry data. Okay, and now we have these points to use instead. If we take a look here, nothing changes because nothing is going to change with this stuff yet. And what I'm going to do, let's take a look at the sim, go to 24 and see how high they get. So let's take a look at the geometry data. Okay, so we have 10 here, we have 12. So between 0 and 12. Okay, let's create a point vol and import the height vector to float. And we're going to remap the height between 0 to 12 to go from 0 to 1. Okay, so now if we take a look at this result, they start black, and then as they go up, they reach 1 at their highest point or somewhere in there. Okay, so I'm going to use this height information to drive the u coordinate. Let me disable this. I copied those nodes. And here I'm going to simply take the point position, take the height, remap it between 0 and 12, and use this to be my u coordinate. Now if we take a look at this, we will see that the points will start traveling through at a random speed, and then they reach the goal. Now they die before they hit the goal, so maybe we need to have them reach 8, so we know that they're all gonna have reached the value of 1. That way they will all hit the end. Actually, I think they're dying much sooner. So yeah, we have to just tweak the sim a little bit more, but this is the idea. You can see the points are now traveling along the curves, and all we have to do is copy a sphere to them. Let's change this, and now we have our points traveling along the curves. Let me template the wires. Okay. Oh, sorry. And we have to make sure that we're looking at the correct frame. So it's this one. Okay. You can see the points are exactly overlaid correctly, and that's the geometry that I'm going to use to render for the lighting. Okay, and I think that's pretty much it for this lesson. I'm going to switch to my scene that has everything tweaked, and I will share both of them so you guys can see the difference. I think it's just a matter of tweaking this and the fit range to get all the points to reach the same goal. I think the variation is also quite high here. And again, please think of another simpler way that can get a randomized number to loop. I think using the point number, using the dollar frame and having a number that repeats based on that, just using a point VOP should also work, and maybe you can add some randomization in point VOPs. But I will leave that to you guys to explore. And the next video I'll switch to the scene, basically have just the cables and the animation of the points that I had before, and then we're going to do some lighting. Thank you guys for watching, and see you in a bit.